Okay folks, welcome back to another installment of our Microsoft 70-687 exam prep course covering Windows 8.1. Today we're going to be talking about Lesson 14, which includes NTFS Permissions. And we're going to be covering Exam Objective 4.2 today. So what are we going to be talking about? Well, we're going to review once again the different types of permissions that Windows has, and then we're going to start focusing on NTFS. NTFS permissions and being able to effectively manage NTFS permissions are kind of the bread and butter for most administrators. So we're going to spend a little time talking about that today. We're also going to elaborate on security principles, ACLs and ACEs. What are they and what do they mean as far as setting up and running NTFS permissions? We're going to look at basic versus advanced file permissions. We're going to talk about allowing and denying permissions. What's the difference and how do they affect our effective permissions with NTFS? We're also going to talk about this whole concept of inherited permissions. If you're familiar with file systems, inherited permissions should be kind of a review for you. And we're also going to be looking at encrypting with EFS and how EFS versus compression, what's the difference, and the fact that they are mutually exclusive. And we're going to be covering disk quotas as well as auditing our data objects. And last but not least, we'll talk about file ownership. After the summary, if we got some time, I'm hoping we'll get a chance to demo some of this on our Windows 8.1 machine. So let's go ahead and get started. First of all, just to elaborate, there are 4 types of Windows permissions. All of these permissions, of course, do operate independently from one another. So it's easy to get these permissions confused if you don't use them and interact with them on a day-to-day basis. Share permissions we discussed in Lesson 13. And in a nutshell, we use share permissions to do just that, to share data among users on a network. And we can use share permissions to gain access to the data or to the data folders, but then we will use NTFS permissions to provide that granular access control over those particular files or folders that we're sharing, whether we're sharing it over the network or if we want to share data on our local machine. We may not need share permissions to share that data, but we will use those NTFS permissions on the local machine to establish what kind of access our local users will have to that data. We also have registry permissions, which are used to provide access to certain parts of the Windows registry components. We'll talk about that at some other point. And then Active Directory permissions. This is something we'll get into more when we start talking about Server 2012 R2 and using domain controllers, and how Active Directory permissions or allowing users access directory permissions on the Active Directory tree, both as a means of reading the Active Directory tree for a standard user as well as administering the Active Directory tree and organizational units, particularly within an Active Directory tree, as an administrator for a domain. So these are the 4 different types of Windows permissions that we use in our environments. Today we're going to focus on NTFS permissions. And in order to understand NTFS permissions, there are 3 terms that we need to get off our plate immediately. First of all is the concept of security principle. A security principle, quite simply, is the name of a user or a group that you have established in your users that are going to, it could be a device even, that you are going to be giving access to a resource. We call any of these users, groups, or devices a security principle. Access control entry, this is a term that we use for basically any kind of permissions that are associated with a particular security principle. They could also be permissions that are denied to that principle for a particular resource. And if you will look at a particular data resource, say we open up a folder on our file system and we go into the properties and we look at permissions, what we are doing is we're actually opening up and looking at what's called the access control list. The access control list, quite simply, is a collection of these access control entries for a particular resource. And each time you look at a specific user or group, whether it's system or administrator or Jane or Neil0029, each one of those security principles is entered as an access control entry in that access control list. Okay, with those three terms defined, let's move on specifically to NTFS permissions. First of all, NTFS permissions are only available on drives that are formatted with the NTFS file system. Bear in mind that Windows 8.1 still supports FAT32 and some other additional file systems out there. But as far as NTFS goes, you could not ask for a better file system to provide that granular level of control over access to resources, whether it's on the local machine or on the network at large. This is why NTFS is really the file system of choice for most administrators in most corporate environments. Okay? We can adjust, NTFS file permissions can be adjusted on a file system resource through the Properties and Security tab. So if you go into a file folder and you right click on it, you choose Properties. In the Properties field, you're going to see a Security tab. It's the second tab usually in that Properties field, and that's going to give you access to that access control list where we can begin to change these permissions for our security principles. Now, basic permissions are going to include what we call full control. Full control is when we give a security principal complete access to that resource. They can do everything from read and execute that data all the way up to controlling the ownership of that data, as well as being able to control the permissions of that data. Okay? Modify access is when we go in and you can allow a user to modify the data, but they're not going to be able to control the administrative aspects of that data. Read and execute is just like it sounds. You can read and execute, if it's an executable, any code in that file. And then of course there's read and write. Now these are all standard permissions, we call them, or basic permissions, and they're really made up of combinations of advanced permissions, of which there are 14 of. And if you go into the Advanced Permissions tab, you will notice that those permissions are all 14 of them are listed, and if you go in and look for at a particular security principle with basic permissions, you'll see that certain types of those 14 permissions are checked while others are not. While we're on the topic of advanced permissions, one of the nice things about advanced permissions is that I can specifically tailor my access needs to a specific security resource. For instance, perhaps I want a group of people to traverse through the file system, not see any other files or folders other than the ones that they have been given permission to. I can do this by setting up something called enumeration using the traverse access advanced permission and tailor it so that I can actually control what folders and files my users can see, so that only those resources they have access to will be seen in their screen. You can do some really neat things with NTFS file permissions, and we'll talk a lot more about the nuances of NTFS file permissions from an administrative level when we talk a little bit more about Server 2012 R2 in later lectures. Okay. Now bear in mind, like I said before, there are 14 different advanced permissions which I can customize, and I can access those advanced permissions simply by selecting that advanced button there at the bottom of the screen when you're in that security tab for those for that particular resource that you're looking at. Alright, now another thing we need to talk about in detail today is inheriting permissions. Like most file systems, NTFS permissions are going to be passed down from the parent folder of a particular resource all the way through the subfolders and the files within those subfolders. This is what we call inheritance. And if you look on the right hand side of your screen, you will see that I've created a user called Susan, and Susan's been given modify access to the parent folder in this file system. You will see through the arrows that modify permission is by default inherited down to each of the subfolders, and if I were to go to the files in the final subfolder, Susan would indeed by default have modify permissions. This is what inheritance is all about. Using inheritance while creating your file tree structure can reduce administrative overhead in the long run. So, when you're thinking about setting up a new file server, or you're setting up files and folders on your machine, and you have more than one user that's going to have access to that data, it's probably a good idea to think about how you're going to organize that data in such a way that you can minimize the amount of times you're going to have to go into that data and make minute changes to that data so that your users can have the access they need. By effective planning of your file tree, you can significantly reduce how much time you spend administering the data's access permissions. Now, it's important to note that you cannot change a security principal's access level in a subfolder if their level of access has been determined in a parent folder above that level, unless I disallow inheritance. Sometimes, well, often actually, it is important that we'll have to go into a subfolder and disallow inheritance for any particular file or folder so that our users can have a more tailored access experience. For instance, I may create a folder called research, and I may set Susan to have read access to several of those folders by default. In the parent folder, I would say give Susan read access to all this data. But maybe there's a folder where I want Susan to have modify access. Well, I can do that. I will just go into a subfolder and I would choose for her to have modify access. I would propagate that access down through the subfolders in that folder, and then Susan would have read access to a majority of those folders except for the folder that she needed modify access. By disallowing inheritance, I can make changes to those security principals' access levels and give Susan the specific access she needs for her data. In the particular example you see here on the right, once again Susan has modify access in the parent folder, but I only want Susan in this instance to have read-only access. So, in this instance, Susan would have generally modify access to all the subfolders within this element, except for this particular folder where I have disallowed the inheritance for Susan and propagated read-only access to all the subfolders and files in that folder. Now, because I can change how I control the access of my users and groups anywhere within the file tree, it is important that at some point for a particular resource, I understand that those permissions are going to be a summation of all of the permissions I have chosen in the parent folders above it. We call this effective permissions. Effective permissions is the combination of the security principles allow and in some cases deny permissions, whether it's going to be received explicitly to that user or group or as a culmination of various group memberships. There are a standard set of rules that apply to effective permissions. Rule 1. Allow permissions are cumulative. That means that if I give Group A read access and then Group B modify access, if somebody is a member of both groups, they will have modify access for that resource. Rule 2. Deny permissions are going to always override allow permissions. When you think about this, this makes sense, right? You want to err on the side of caution. So if I explicitly give a deny access, that access will override any access that is an allow access. So, in this particular instance, if Susan is a member of the sales group and she has modify access in the parent folder, by default she would have modify access to the subfolders and files beneath it. However, if I change Susan's access For instance, if I say sales, the sales group in which Susan is a member of has denied privileges for a particular subfolder, then Susan will no longer have access to that set of files in that subfolder. Why? Because of Rule 2. Deny permissions will always override allow permissions. Since Susan is a member of the sales group, she will no longer have access to those subfolders. Explicit permissions will always take precedence over inherited permissions. So, if, for instance, I give Susan's sales group modify access to that subfolder, and then I decide that Susan specifically should only have read access. If I have sales have modify access, that would mean everybody in the sales group would have modify access to that data with the exception of Susan. Alright. Now, encrypting files and folders, I have that ability with NTFS. It is a built-in feature that has come out with the very first, well, take that back, the second incarnation of NTFS. I believe we're up to version 4 now. It uses the Windows Public Key Infrastructure, or PKI, to encrypt that data. The nice thing about EFS is that it is seamless to the user. There are some limitations. For instance, EFS is user-specific. I can't really use EFS if for, say, a database in which I have 3 users that will need access to it. If the owner of that database encrypts that database, only the owner will have access to that data. One of the nice things about EFS, though, is that say for some reason that permissions for that database got compromised, and even though I may have modified access to that database when I've stolen it or whatever, because it was encrypted by that user's public key, I would not be able to get into that data. Okay? Another limitation of EFS is that I cannot compress any data that has been encrypted with EFS. Compression and encryption are mutually exclusive. Nice thing about EFS is that it's very simple to implement. If I go into the General tab for the properties of a particular file or resource and then choose the Advanced option, you will notice that in the Advanced option I do have not only the file attributes, but at the bottom I have the ability to either compress or encrypt that data. Disk quotas are less used on local machines, but they are used to allocate maximum storage to users on a per volume basis. That means that for a volume of data, I will go in and I will look at that data's owner, and I will tally up how much space that data has consumed on a particular volume, and then that amount of data will be applied against the disk quota for that user or group. Now, I can tailor the storage needs to specific users if needed. So, for instance, one of my users calls me up and says, my 50 gigs of space is full and I can't I need to store this particular data. As the administrator of a device or network, I will have the option of increasing the disk quota for that specific user. I can also reduce it for that specific user if I see fit. So, even though by default I will apply the same disk quota to all my users when I set it up, I can go in and specifically make changes to those disk quotas. So it does provide a very high level of flexibility once it's implemented. It's a great way to ensure that you are maximizing your space on a particular medium resource. Another interesting benefit of NTFS is this whole concept of file access auditing. We use auditing, or we audit events on systems all the time. We have security logs and system logs and application logs and we're auditing system events all the time. But we can also audit specific access to data. This is really good if we want to monitor, say, secured data and see who's getting into it, what they're doing with that data, or maybe we need to be alerted if certain people are accessing data when they shouldn't, or attempting to access data when they shouldn't. And we can determine when we set up auditing whether we want to be notified for successes or failures or both. So, access auditing allows me as an administrator to basically track whether those attempts are successful or failed attempts, doesn't matter, my choice, to anyone or any type of access to folders or files which I've chosen to be monitored. Now, there are two parts to initiating auditing. First of all, I have to audit the group policy, and I do that by going into the command line and typing gpedit, launching the group policy snap-in for my 8.1 Windows Professional or greater computer, and I can set the audit access in the audit policy to audit the successes, failures, or both if I see fit. Now, I do want to point out at this point, it's not really mentioned right here, but auditing is a very resource-intensive task. Not only does it use up certain resources on the machine, but it also is a storage medium hog. When you are auditing events, you are creating a log entry for each of those events, and in some cases multiple log entries for each of those events. So it does not take long to end up with literally millions of logs to look through to allocate or determine what's going on with certain things. Therefore, we don't want to just go in and audit everything. We want to be very selective over the events that we wish to audit based upon our environment's security needs. So, this is something, when you start setting up auditing, it really is something where you need to have a dialogue with the other administrators in the group, determine what events warrant your attention, or what events are required by law, for instance, to be recorded, and so on. Figure out a way to store those events and to recall those events in a timely manner before you actually set up this whole concept or initiate this file auditing. Okay. Now, file access auditing, once again, usually not implemented on a local machine as far as typical users are concerned, but it is something we do on network environments quite often, particularly for sensitive data. We like to put sensitive data in specific folders. We'll lock down those folders, and then we'll set up file auditing only on those folders that we deem necessary to keep track. Okay. So, the second part of that, after we have turned on the audit object access through group policy, is going in and selecting the specific folders and in some cases files that I want to audit. And I'm going to configure my security principles for each of those folder or files that I want to audit. Generally speaking, we like to do that in groups. Group management is very important in our business as far as controlling access to resources. Also a good thing to do for auditing. So we could very easily say authorize users as a group, and then create that group in the auditing, say anyone who's an authorized user, we want to look at their access practices to this data. Alright, file ownership. Anyone who creates a file or a folder will become that object's owner. That will allow the user to be able to administer the object's properties, things like setting the permissions. Even if I, the owner, don't have permissions to that object, I still, as the file owner, can affect the property's permissions. And I can also choose whether I want to encrypt it or compress it and do some other administrative things on that particular object. Now, as I said before, disk quotas are going to be calculated based on object ownership as well. And it's also important to note that as an administrator, we can revoke anyone's ownership and take ownership, which eliminates the possibility of orphaned and inaccessible data objects. We call this the administrator's backdoor, and it is our way of being able to reclaim access to an object even if our permissions have been removed. Now, one of the interesting things that you can do, since we were on the topic of auditing, is say we're in a high security environment. Well, administrators can, by nature, have access to, say, top secret information. But if I set up auditing on that top secret information and I regulate who's going to control the auditing or maintain vigilance over the auditing portion of it, I can effectively watch and make sure that my administrators are not getting into any top secret data unless they absolutely have to. This is where the whole auditing thing comes into play as a method of really clamping down on an object's security. So, that's lesson 14 pretty quickly. So let's summarize before we actually move into the demo section of this lecture. So, there are 4 types of Windows permissions out there that you need to know about. Bear in mind that each of those permissions do operate independently from each other. One of those permissions, NTFS permissions, provide the most granular way to manage access to files and folders, particularly when compared to other supported file systems. Basic permissions consist of full control, modify, read and execute, read and write. And bear in mind that these basic permissions are really combinations of those advanced permissions, and if you go in and look at those basic permissions for each particular user, you can see or get a feel for how those basic permissions are set up using each of those advanced permissions. NTFS permissions are going to be applied to security principals, whether they're users or groups, which are then stored in what we call access control entries on the access control list for the object it's protecting. Sometimes setting a standard permission for a user group is not going to be enough, so you're going to have to go into the advanced permissions in order to tailor a solution, and you can do that by selecting the advanced button and then editing or adding a security principal or even removing a security principal in the group. Bearing in mind that when you do the advanced permissions, you have a combination of 14 separate permission entries that you can choose for that security principal or a combination thereof. Like most file systems, NTFS file systems does use inheritance. That inheritance propagates from the parent folder unless I specifically disinherit those permissions and then alter those permissions at that level of access where I want to change it for that particular security principal. Then I'll have the choice of propagating those newly changed permissions from that point forward down into the subfiles and folders. And once in a while we may not do that, but in general we do want to propagate those permissions to the subfolders. You can assign and alter permissions to security principals anywhere in the file tree. So bear in mind that the effective permissions for an object in the file tree is going to be the sum of all the cumulative access permissions and denials from the parent folder all the way down to the particular object that you're looking at. And you can effectively look at effective permissions by going into the Effective Permissions tab in the properties for that particular object that you want to examine. Deny permissions and explicit permissions for a particular security principal are going to take precedence over allow permissions. So it's important to remember, use deny permissions and explicit permissions sparingly, particularly on multi-tier data environments, in order to prevent some confusion. Encrypting file system, or EFS, allows owners of files and folders to encrypt the data so that only they have access to it, even if it's moved or if the permissions are going to be compromised. Disk Quotas allows you as an administrator to conserve space on a volume by assigning users the maximum space allowance that you wished for them to have, bearing in mind that Disk Quotas is a very flexible tool where you can tailor it to specific users' needs. Auditing files and folders is a great way to ensure security, particularly on sensitive data. It requires configuring the group policy for object auditing as well as assigning auditing on specific data objects. This is best done with groups of users, say authenticated users. Remember, use auditing sparingly as it is resource intensive. Anyone who creates a file or folder will become that folder's owner for administrative purposes. And bear in mind that you as an administrator have the privilege of being able to revoke or reassign ownership as needed to administer the file system. Okay, that's it for lesson 14. Okay, so welcome to the demo portion of our segment today. Today I want to combine a little bit of lesson 15 and lesson 14 together, primarily because I want to set up basic NTFS permissions for a user on our box, and then we're going to also play with a group at the same time. Now, what else am I going to do today? Well, while we're there, we're going to create a file and put it in that folder. We're going to assign EFS permissions on that file, and then we're going to see how EFS permissions work when someone else tries to access that file. Last but not least, we are going to show you very briefly how to set up disk quotas for a volume. So let's go ahead and get started with these little segments for the day. So first thing I want to do is I am going to go in and set up a local user account. Now we could do this from the desktop or from the Metro screen by going in and typing system and bringing up the system resources and going into users. But I want to go in the back way today, primarily because the back way is easier, particularly when you have a computer that's set up on the domain and you want to set up a local account instead of a domain account for those users. So without going into domain accounts and local accounts, we'll cover that in lesson 15, but we're going to be setting up a local account today. So let's go ahead and just go into the control panel. In the control panel, I'm going to go to Administrative Tools, Computer Management, and in the Computer Management you will see something called Local Users and Groups. In the Locals and Users and Groups segment, we do have your default groups. All of these, with the exception of this Group 1, this test group that I created earlier for our example today, are default groups that are affiliated with every Windows box that comes right out of the box. And this is true for the administrators group all the way up to remote desktop users group. All of these are default groups associated with a typical Windows single user operating system. Now, the users group, if you go into the users group, I have renamed, this was the administrator, and I've renamed it YLead, and I renamed it for a reason. By default, if I go into this administrator's account, this is an administrator account, you'll see that this account, by default, when you buy Windows 8, it's disabled. And this is actually something that they started doing since Windows 7. And they do this as a security measure because most people, when they build their box and they're going to build it with their default account, that default account is going to have administrative privileges. It's going to be named, after them or their dog or whatever. The administrator account, unless you are astute enough to go in and change that administrator account name, when someone tries to break into the box and they're going to use a brute force attack, what account do you think they're going to target first? Well, of course, the administrator account. So if we disable that account, that makes it extremely difficult for them to break into the box with the administrator account. Well, never fail because, chances are the account you're using on it's got administrative privileges anyway. But I do want to point out that this account is disabled. I always recommend, particularly in a corporate environment where we often use the administrator account as a backdoor into our boxes, I always recommend that you rename the account. Now we can do this if it's on the domain. We can actually do this through group policy. We can roll out these changes on a massive scale. Or we can do like we've done here and rename it on the box, and then we can image that box and deploy that image over the network. Either way, the effect is the same. We've renamed that administrator account, giving it a little bit more security. So if you want to rename an account, by the way, if you go into here and you go into properties, this is not the name of the account. This is just a descriptive field of who it is. In this case, it's Jane. I could say Jane Simpson. James Simpson does not change the name of the account. The account is still Jane. So when someone says make the account name this, they don't mean put the name of the account, the user account in there. I mean, they want the name of the account itself. So we're going to create an account today. We're going to go into new user. The user's name is going to be Susan Smith. That's her name. The account is going to be Susan. We'll get to that part. Username is, the username is going to be Susan, because that's the example we used in the book. Her full name is Susan Smith. It's getting late. I'm going to uncheck this user must change password at next login just for the sake of our example today. In general, we don't want to change that. This user cannot change password here. This is particularly useful, particularly if I'm creating a service account. A service account is an account, it's basically a user account, but it's a user account that some machine is using in order to accomplish some automated task. We call that a service account. In this instance, I'm going to say this password never expires. So I'm going to say create and close, and you can say Susan, there she is, she's been created. Very good. So I'm still logged in as student. I have administrative privileges on the machine, and I am going to go in and I am going to create, through the File Explorer, I'm going to create a folder for her. I have this enabled inheritance here on the C drive so that I can create accounts. So I say new folders. I can say Susan's data. Okay, and I'm going to go into properties here, and I'm going to add Susan, and I'm going to say edit, and I'm going to say add, and I'm going to say Susan. Okay, and you notice I was able to add Susan Smith with no problem here. And you want to know why? Because Susan's not been mentioned anywhere in any of the parent folders. So this is a new permission for her, and I want to give her modify privileges. I'm going to say OK. Okay. And you notice, though, if I go into administrators and I want to edit it, those are grayed out. And that's because it has inherited those permissions for, in this instance, authenticated users or administrators. It has inherited those permissions from the root of C, or the parent folder, which is in this case the C drive. Okay. Now I'm going to do this. I want to show you how to disallow inherited permissions. So we're going to do this by creating a subfolder in there, new folder, and I'm going to call this Susan2. And in this instance, we're going to go into properties. We're going to go security, Susan Smith, edit, and oh my gosh, I can't edit her. Well, I can't edit anyone in here because they've inherited permissions from Susan's data. So what do? Well, I'm going to cancel out of this, and I'm going to go into the advanced permissions, and I'm going to click this button that says disable inheritance. I'm now disallowing inheritance. Now I have a choice. I can convert the inherited permissions into explicit permissions. I highly recommend this. Or I can remove all inherited permissions from this object. Now, why do I choose this option over this option? Well, this option is right 99% of the times that you're going to be altering permissions and blocking inheritance. Why? Because chances are you don't want to change but one or two things in that folder. And if you remove all the inherited permissions from that object, what's going to end up happening is you're going to have to rebuild all those permissions from scratch. And chances are you're not even going to remember all those permissions. So trust me on this. The best thing to do is say convert the inherited permissions, keep them as they were originally written, and then go in and alter or edit each of those permissions as you see fit. In this particular instance, the only thing I want to do in here is read and execute. So I'm going to say read and execute. Well, okay, let's just do read, because read and execute does mean I have to list the folder contents, and I'm just going to say read. And I'm going to say OK. Okay. And then I'm going to say OK. And you'll notice that she now has read-only permissions to that folder. So That's what happens with Susan too. Now let's go into here and we're going to create a new text document. We're going to call it new text for Susan. Okay. Now this new text for Susan, if I want to go in and look at the properties for that, I am the owner of this folder. I can go into the security for this and I can see that Susan has modifier privileges for this folder. Why? Or for this file. And that's because when I created it in a folder that Susan has modifier privileges. Okay, if I go into the advanced one, go into here and I try to remove her, it won't let me remove it because it still is inheriting those permissions. Alright, so now I can go in here and I can say through the General tab, Advanced, and I can encrypt the contents like so. Now I'm applying EFS permissions on this. I'm just going to encrypt the file entry today because I want to show you something. And you'll see that this has changed to green. Okay, you also see that you got a notice here to back up your file encryption key, because as you remember, this uses PKI as a method of encrypting this file. And because of that, I now have a key associated with this account, and I'm going to want to back up that key. I can say back up now. I'm going to back it up, and we'll say yep, I'm going to export it and all the extended properties. Next, I'll create a password, 123, 123. Next, I'm going to call it backup 2. Next, and I'm going to finish it, and now my export was successful. That allows me to have a spare key. In the event that something happens to my key, I now have a spare key that I can use and import into my account so that I can access my data, because if something happens to the key, my data is lost forever. Alright, now remember, I've created this new text for Susan as student, which means that Susan didn't create this. I created it with my own account. Now, so what's going to happen when Susan tries to access it? Well, we'll see in a minute. There's another thing I want to do before we log in as Susan, and that's go in and show you how to, through the control panel, administrative tools, computer management, and we're going to go into disk management at this point, and we're going to quickly enable disk quotas. Okay, and I can right click on this particular volume. Remember, it's volume based. Go into properties, find quota, enable quota management, deny disk space users to users who exceed that quota limit. I'm going to limit my disk space to 1 terabyte each, and then I'm going to log the event whenever someone exceeds that quota limit. Okay, so that's how you set up quota entries. And then you can go in, as you can see, it is now building an entry list of all of the users affiliated with this box, and it's going to tell me how much of their space they have used. In this case, Jane Simpson has 78.68 megabytes worth of data stored in this volume. This is very powerful stuff here, because I can go in and I can say properties, and I'm going to change her. I'm going to say I want her to have unlimited disk space. Done. Jane Simpson has unlimited disk space. She's the only one that has unlimited disk space. So this is a very flexible. Don't be scared by setting quotas and automatically sets quota to everybody. You can always go back in and be flexible with those quotas as you see fit for your users. All right. So we're going to log off here. Sign out, and we're going to sign in as Susan. Okay, so bear with me. We're going to sign in as Susan Smith. Now you notice it says Susan Smith here. That is not the account name. The account name is Susan. It just says Susan Smith. That's the display name that you chose when you set it up. Okay, so we have finally built the profile for Susan. So let's go in and let's see what happens. Now that we have done that, we can, first of all, this is her new desktop. Our profile's been created. These are the library files. We talked about libraries earlier. These are the library files that were set up for her. So I'm going to create a new document. And I'm going to call this Susan made this. Okay. We're going to right click on this and we're going to properties. And you'll see the properties on this is that Susan has full control. Why? Well, because she is the owner of this document. We're going to copy this. We're going to go here. We're going to go into Susan's data and we're going to paste it in here. Look at that. It worked fine. Now here is that encrypted document that student made earlier. Can I get into it? It's in my folder. I have, as Susan, I have modify privileges to this folder, right? I actually, yeah, see modify privileges. So let's go in here. I should be able to open it. Access is denied. And access is denied because I don't have the encryption key for that file. Now, okay, so I do have this file. I'm going to right click on it. I'm going to copy it. And I'm going to put it in Susan 2. Now, if you remember correctly, Susan 2 here, properties, security, Susan has read-only access. So that tells me that I should not be able, as Susan, to paste this file into this folder. But I was. That doesn't make any sense, does it? Let's go back and look at that again. Let's look at the properties of this. You'll see that even though Susan has read-only privileges, Susan is a user and an authenticated user. And an authenticated user has modified privileges to this folder. Now, what does that mean? Let's go into the effective permissions. By the way, you see student still owns this folder, right? Student's the one that created that folder. If I go into here and I select Susan and I check names and I hit OK and I view the effective access, you will see that I do indeed have right attributes associated with this file. This is a very important lesson, and I will explain why. If I really wanted to make sure that Susan only had read privileges, I would need to go in and delete. Let's go in as student. And let's delete authenticated users. Who else? And users. System's fine and administrators is fine. Okay? Okay. Now, let's create a new folder. And we're going to call it Test Me. Now, I want to copy this folder into Susan 2. And remember, now I'm just Susan 2. I get a denied access. So, that's a very important lesson about effective permissions and how it's important to evaluate all of the groups and users affiliated with a folder before you decide that you have given the proper access. Okay, that's it for today. I look forward to seeing you in Lesson 15.